In this video, we are going to write down the constitutional isomers of C5H12O with the ether functional group. In a previous video, we wrote down the constitutional isomers of C5H12O with the alcohol functional group. Link is given in the description. As you already know, this is a completely saturated elemental composition with the degree of unsaturation equal to 0. That means that no carbon-carbon double bonds or cyclic structures are possible. This is strictly no. Let's write down the structures one by one. I am going to write down the structures both in condensed form as well as in bond line notation. Number 1, we can write butyl methyl ether, that is CH3O, CH2, 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 CH3, and the corresponding structure in bond line notation will be CH3O and then CH2, 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 CH3. Let's number it 1, 2, 3, 4. We have our methoxy group here. Therefore, the IUPAC name is 1-methoxy butane and the common name is butyl methyl ether. And then number 2, we can also write isobutyl methyl ether, that is CH3O, CH2, CH, CH3, CH3, and the corresponding structure in bond line notation will be CH3O, CH2 and then CH, one methyl group, another methyl group. Let's number it 1, 2, 3. We have a methyl group at 2 position and the IUPAC name for this is again 1-methoxy. We should not write the methyl group first because as per alphabetical order methoxy wins. 1-methoxy 2-methyl propane, that is the IUPAC name, and the common name is isobutyl methyl ether. One easy way to remember about isobutyl is there will be a methyl group at 2 position. And then number 3, we are going to write secondary butyl methyl ether, and that is CH3O and then CH, CH3, CH2, CH3. In this case, the numbering has to be done from here 1, 2, 3, 4. This is 2-methoxy butane and the common name is secondary butyl methyl ether and the corresponding structure in bond line notation will be CH3O and then CH, CH3 and then CH2, CH3. And then number 4, we can also write tertiary butyl methyl ether, CH3O and then carbon, CH3, CH3, CH3. This is a tertiary carbon, therefore this is tertiary butyl methyl ether, that is the common name, and the IUPAC name is, let's number it 1, 2, 3. 2-methoxy 2-methyl propane, that is the IUPAC name, and the corresponding structure in bond line notation will be CH3O and then the tertiary carbon having 3 methyl groups. And then number 5, we are now exhausted with the methoxy option. Now let us go to the ethoxy option. Therefore, CH3, CH2O, CH2, CH2, CH3. This is ethyl propyl ether, that is the common name. Let us number it 1, 2, 3. That is our long continuous carbon chain. And therefore, the IUPAC name is 1-ethoxy. Now, instead of methoxy, we have the ethoxy group here. Therefore, 1-ethoxy propane, that is the IUPAC name. and the corresponding structure in bond line notation will be CH3 CH2O and then the propyl chain 1 2 3 1 2 3. We can write one more isomer and that is ethyl isopropyl ether. So, we have CH3 CH2O and then CH and then CH3 CH3. This is ethyl isopropyl ether and the corresponding structure in bond line notation will be 1 2 and then the oxygen atom and then the isopropyl group on the other side. Let us number it 1 2 3 and the IUPAC name is 2-ethoxypropane. You shouldn't number from here thinking that there is a methyl group here, that would be wrong. 1 2 3. Therefore, in total we can write 6 constitutional isomers for C5H12O with ether functional group. If they are asking all isomers including stereoisomers, then the answer should be 7 because we have a chiral center here. The secondary butyl methyl ether has a chiral center and therefore one chiral center means total number of stereoisomer is 2, isn't it? And therefore there the answer should be 7. If they are asking both constitutional isomers as well as stereoisomers for C5H12O with the ether functional group, then the answer should be 7. This is constitutional plus stereo isomers for C5H12O with the ether functional group.